Good afternoon, all of you. Good afternoon. And please give me a confirmation message. Am I audible to all? So this is a complete schedule of the crash course. On every Saturday and Sunday, we are going to discuss some subject, that is analog circuit. I am going to discuss from 12 p.m. to 2 p.m. and digital electronics is going to discussed by Bhima Shankar sir from 9 a.m. to 11 a.m. and electrical machine Ankit Goyal sir will discuss from 4:30 to 6:30, and after that in the evening Vishal Soni sir will discuss engineering maths from 7 p.m. to 9 p.m. on each Saturday Sunday. This is the schedule. Once these subjects are finished, then we will go for the next subjects, and like that your complete crash course will be there before GATE 2021. Okay, so first of all, a brief introduction about myself. Dear friends, I am Kamesh I am MTech from IIT Roorkee. I have 5+ years of teaching experience for GATE and ECE field, and I teach EDC, analog circuit and advanced electronics, and I am teaching EDC, analog circuit and advanced electronics at Unacademy Plus platform as well. On Unacademy Plus platform from 25th of September, I have started analog circuit comprehensive course. Okay, and only 3-4 classes are over. You can come and you can join the Unacademy and you can enjoy watching my comprehensive course of the analog circuit. And EFT is also started on 1st of October by Vishal Soni sir, and that you can join that subject as well. So to join Unacademy Plus, you have to use my coupon code EDC10 to get 10% discount on Unacademy Plus subscription. And what is the advantage of Unacademy Plus subscription compared to these YouTube class and special class? There are various advantage on Unacademy Plus platform. Daily live classes. These live classes are uninterrupted classes. Test series is included in the Plus subscription. Structured schedule is there, and unlimited practice questions will be provided to you so that you can practice all the questions in a well manner. And another thing is iconic subscription of Unacademy, and in the iconic subscription you will get personal mentorship of a teacher. One-to-one personal mentorship will be provided, and study planner will be set up and it is given to you. ECE mains questions and answer practice will be there, and expert guidance will be available for you. In every 7 days your report card will be ready, and then by watching the report card you can improve your performance. That is the advantage of iconic subscription. Now what is the cost of iconic and plus subscription? If you go for the plus subscription for 12 months after application of code EDC10 and after getting 10% discount, you can get 22,500. In 22,500 you can get the Unacademy Plus subscription, and iconic subscription of 12 months you will get in 40,500 rupees after EDC10 coupon code application and after getting 10% discount. Various EMI options, my dear friends, also available at this platform. By EMI options you can also get the Unacademy subscription, in which in every month some amount will be deducted from your account and you will get the subscription. Next thing is that why to take Unacademy subscription very soon? Because the Unacademy fees is going to hike very soon, so that it's better to take Unacademy subscription today, day after tomorrow, or it's your choice whenever you want to take the Unacademy subscription, but it is going to hike fees very soon. Okay, so it's better to take very soon. Okay, now let us start the subject. Okay, so what is the objective of this analog crash course? So in this analog crash course, in a crash course format, we will discuss complete analog circuit, diode circuit, BJT amplifier, op-amp and feedback amplifier and CMOS inverter. All the things I will discuss in this crash course only. Okay, now let us start with the very first chapter, that is diode circuit. And in the diode circuit, when we discuss the diode circuit, we should know about the diode models. So while solving the diode problems, we should know how many diode models are available by which we can replace the diode in any circuit. Suppose we are having one model, that is the very first model, that is the ideal diode model. So in the ideal diode model, what is the meaning of that? Suppose this is a diode current ID and this is the diode voltage VD, and suppose we are having some diode whose voltage is VD and whose current flowing from P to N direction is ID. Now how this diode can be replaced? Now see, this is green color characteristics is there. This green color characteristics is there, that is showing the actual characteristic of the diode in the ideal diode case. What is the meaning of that? What is the meaning of that? When diode voltage just 0 plus, when diode voltage just 0 plus, then sudden current is flowing through the diode, and when diode voltage 0 minus, diode current is equal to 0. Meaning is that if we are having some ideal diode, we can replace this diode by either open circuited, why open circuited, because its current is 0 in the reverse bias case, or we can replace this diode by short circuited, because in the forward bias case or in the on condition it is having some current flowing through it in the P2N direction. So sir, first of all we will have some brief idea about the diode model, and then we will enter into the problems and we will solve many number of problems in this lecture. Okay, now when the diode is having 0 plus voltage across it, diode will become on, and diode will become on, then diode will become short circuited, and diode can conduct any amount of current from P to N direction. P to N direction, any amount of current it can conduct, but voltage is approximately equal to 0. That means it is short circuited. And in the open circuit case, current is flowing through the diode is 0, because in the open circuit case or reverse bias case, diode current is given in the characteristics is equal to 0. That's why it is open circuit. So we can open circuit diode or short circuit the diode. In the short circuit, current is flowing. In the open circuit, current is equal to 0. But no doubt, in the open circuit, we can measure the voltage across the diode. Now second model of the diode is this. This is the second model of the diode. In the second model of the diode, my dear friends, what is there? What is there in the second model of diode? When current ID and VD is given across the diode, suppose we are having second diode, this is second diode we are having, and diode is having some voltage VD and some current ID is flowing through the diode, then how we can replace this diode? Let us see. This is the diode cut-in voltage V gamma. What is the meaning of that? What is the meaning of that, my dear friends? When voltage across the diode is less than V gamma, current is 0. What is the meaning of that? When voltage across the diode is less than V gamma, current is 0, meaning is that diode will become open circuited. When diode voltage become equal to V gamma or greater than V gamma, sudden current is flowing through the diode, meaning is that diode will be replaced by some battery, because a battery is an element whose voltage remain constant and current can take any value from P to N direction. So this is a brief idea about the diode models we are giving. After that we will solve many number of problems on these diode models and diode circuits. Okay. Now see, third case is also given. In the third case, what can happen is a diode is there, one diode is there, practical diode we are having, and suppose some cut-in voltage V gamma we are having, and diode characteristics is like that. This is the third case of the diode characteristics, where diode is conducting current no doubt after V gamma, but it is also having some slope. What is the meaning of slope on the IB plot? On the IB plot, if we are having some slope, what is the meaning of that? Slope on the IB characteristic is nothing but a resistance. So now find the slope of this line. If we calculate the slope of this line, slope is equal to delta ID upon delta VD. Slope is there. Slope is nothing but the resistance. So we can calculate resistance of the diode RF equal to 1 upon slope. Why 1 upon slope? Because slope is current upon voltage and resistance is voltage upon current. That's why reciprocal of slope will give you resistance. That's why RF is equal to 1 upon slope, or RF equal to delta VD upon delta ID. Now what will happen? Again we are having, suppose diode we are having, and suppose diode voltage VD is less than V gamma, then current is 0 only, diode will become open circuited. But when the diode voltage is greater than V gamma, diode will become on, and diode is having some cut-in voltage of V gamma as well as some slope, that is meaning of resistance is present, meaning is that we can replace a diode by battery as well as by resistance. This is the replacement of the diode. Okay, diode cut-in voltage V gamma and diode resistance R from P to N direction. That we will do, and some current ID is no doubt flowing through the diode from P to N direction. So this is a brief idea about the diode 3 models: ideal diode model, short circuit, open circuit. Practical diode model: suppose diode resistance is not given, diode will be replaced by either battery or open circuited. In the reverse bias off condition, open circuited always, okay. And the forward bias condition, replaced by the V gamma. And if the resistance is given, replaced by V gamma and resistance. So that is the replacement of the diode. Now we will go for the very first question of this diode circuit chapter, okay. First question. The circuit is given, dear friends, we have to calculate. Ideal diode is given, that is mentioned in the question, ideal diode. If something is not mentioned about the diode condition or diode type, then by default we will assume diode is ideal, okay. So now ideal diode is given, we have to calculate this voltage V0. Now what is the procedure to solve this problem? Very simply, the simple idea to solve this problem is nothing but, in any circuit where diode, BJT, resistor and some voltage, Zener voltage regulator is there, or some op amp are there, and diodes are there together, then first thing is to identify whether diode is on or off. In any circuit where diode is involved, first to check the condition of diode, whether diode is on or off. In this circuit we don't know whether diode is on or off. We don't know whether diode is on or off. It can take on condition also, it can take off condition as well. So meaning is that first let us check whether diode is on or off. After that, knowing status of the diode, then we will calculate the output voltage V0 or this voltage of this 2 ohm resistor, okay. Now let us take diode may be off, diode may be on. What we can assume? Let us assume diode on or off. Let us take on. Suppose I am assuming diode on. Let us take diode is on, okay. Let us assume diode is on. Let means assumption. If we are assuming diode on, diode is ideal. How ideal diode is replaced? I told you, ideal diode is replaced by the short circuited in the on condition, and in the off condition it is replaced by the open circuited. So open circuited in the off condition, on condition it will be replaced by short circuit or by battery and resistance, depending on ideal diode or V gamma diode or V gamma and resistance diode, okay. Now diode, let us on diode, okay. So now what is the circuit you will get? You will get this circuit. If diode is on, this is the diode, okay. And here we are having 4 volt battery. Here also we are having some 2 volt battery. Okay, let us solve this problem. Very easy problem. We will go for some difficult problem as well. Okay, now diode is on. This is 2 ohm resistor. Okay, we will calculate V0 in last. In last calculation will be V0 only. Here we will calculate first of all whether diode is on or not. Okay, first we will confirm whether diode is on or off. Okay. I am assuming diode on. What is the meaning of that? I have assumed diode on. Okay. This is the P terminal of the diode, P N terminal of diode. Now, when you are assuming any diode on, what is the meaning of in the on diode? In the on diode, we can have some current. Because we are taking diode short circuited, there is no meaning of checking the voltage across the diode. So now what we will check? We will check some current across the diode. That is called short circuit test. Okay. Now let us take current ID is flowing through the diode from P to N direction. Now in this circuit we will calculate this current ID. If this current will come in P to N direction, yes, it means really diode is on. Our assumption is correct. If suppose we are calculating the ID in this circuit and we are getting ID in N to P direction of the diode, then really diode is off. Are you getting it? And our assumption is wrong. So now let us check what is the value of diode current ID. Let us take this node voltage as Vx. Apply some nodal analysis. Okay. Some current I is coming, some current I is going, and some current here is going. What is the nodal equation? Some current is coming, some 2 currents are going. What is the incoming current? 4 minus Vx upon 2 ohm is equal to Vx minus this voltage by default 0. Vx minus 0 upon 2 ohm plus Vx minus 2 volt. Vx minus 2 volt upon 2 ohm. Calculate the value of Vx. How much we will get? 2 cancel out. 3 Vx equal to 4 plus 2, that is 6. And Vx equal to 2 volt. What is the meaning of that? If you are getting Vx equal to 2 volt, what is the meaning of that? If Vx is 2 volt, what is the current ID? We can calculate. What is the current ID now? What is the current ID now? Vx minus 0 upon 2 ohm. Vx minus 0 upon 2 ohm. What is the answer of ID? Vx minus 0 upon 2 ohm. 2 minus 0 upon 2, 1 ampere current. What is the direction of this ID? ID, we are getting positive current from P to N direction. What is the meaning of that? ID, we are getting 1 ampere and this current is flowing from P to N direction. P to N direction current is flowing. What is the meaning of that? In any diode, when current is flowing from P to N direction, it means that this diode is on. Are you getting it? Meaning is that really this diode is on. Really, this diode is on. This diode is on. Meaning is that our assumption is correct. If your assumption is correct, meaning is that in this circuit, this diode is on only. And if this diode is on only, now you can calculate the answer of V0 because this circuit is exactly representing this circuit because we have assumed diode on and by checking it we are getting diode on only. Meaning is that if this circuit is existing correctly, it is existing. Now what is the relation between Vx and V0? Vx is this node voltage plus minus, that is Vx only. Now what is the relation between Vx and V0? That is nothing but we are having V0 equal to minus Vx. V0 equal to this V0 equal to minus Vx. And what is the answer of Vx? That is 2 volt. That's why V0 equal to minus 2 volt is a correct answer for this problem. Correct answer for this problem is V0 equal to minus 2 volt. Any problem? This is a simple procedure to solve this question. Okay. Like कीजिए, share कीजिए. Okay, and maximum to maximum share this video so that maximum student can join and can get the benefit of the crash course and can score maximum marks in the GATE examination. That is our objective. Okay, now let us go for second question. This is the second question we are having on the screen. Okay, D1, D2, 2 diodes are there. In the earlier problem we were having one diode, single diode. Now we are having 2 diodes and 2 battery, 10 volt, 4 volt, 10 kilo ohm, 10 kilo ohm and 10 kilo ohm. Find V0, that voltage, this node voltage V0 we have to investigate, we have to find out. Now the point is, again this is a diode circuit. I told you, without knowing the state of the diode, don't solve the problem. So meaning is that to comment on the answer of V0, first of all check the status of D1 and D2. How to check status of D1 and D2? How to check? Let us assume some condition. 2 diodes are there. What are the possible conditions? Both are on, both are off, D1 on, D2 off, D2 on, D1 off. Out of 4 possibility, only 1 possibility will be correct because all the sources are the DC source. DC sources means what? All the node voltage are DC voltage. All the node voltage are fixed. All the node voltage are not changing with time. Hence diode will have only one status. Either both are on, either both are off, or D1 on, D2 off, or D2 on, D1 off. So now let us check. How to check? Just assume any one of the condition. What you can assume? You should assume the condition for that you are having a strong feeling. What is the strong feeling? This diode D1 is having P terminal voltage of 10 volt. Hence it should be forward biased. Okay. Now if this is forward biased, this diode is on. If this diode is on, 10 volt will come at this node. If 10 volt will come at this node, this second diode D2 is having 10 volt on the N terminal and 4 volt on the P terminal. Any diode is having P terminal voltage less and N terminal voltage higher. That means that D2 will be off. Meaning is that what we should assume in this out of 4 condition, we will assume let D1 on, D2 off because we are having more probability, more chance to do D1 become on and D2 become off. So let us assume D1 on and D2 off. Out of 4 conditions, we don't know which one is correct, but we are having a strong feeling that this condition will be true in this circuit, that we are having strong feelings. Okay, let us check. D1 on, D2 off. Now diode is ideal or non-ideal? Ideal diode. What is the meaning of ideal diode? If you are assuming any diode on, replace it by short circuit. If you are assuming any diode off, replace by open circuited. So now let us replace the circuit. Okay, this is the complete circuit we are having. Okay, Now D1 is on, D2 is off. How to take decision whether D1 is on or not? So let us check. Let us investigate. Let us investigate in the circuit. Investigation should be proper. Then only you will come to know whether diode is on or off. Okay. So now D1 is on. We are assuming. Just make it short circuited. It is P side. It is N side. I will assume some current flowing through the diode D1 in P2N direction. Now this voltage is 10 volt. Okay. This voltage is 10 volt. Now this resistance is 10 kilo ohm. What we are assuming? D2 off. Off means open circuited. And when we are assuming any diode open circuited, always check voltage across it. So we always check voltage across the open circuit diode and current across the short circuit diode. We always check like that, okay? Because in the open circuit, we never judge the current because current is always zero in the open circuit. So in the open circuit, we check for the voltage, and in the short circuit, we always check for the currents. So now check the current. If in the D1 diode, current will come from P to N. After calculating the current, if we are getting current in P to N direction, then really diode D1 is on. Now if we are checking voltage in the D2, if VD2 is coming positive, what is the meaning of that? It is the P side of a diode and this is the N side of a diode. If VD2 is coming positive, it means P terminal is having higher voltage compared to N terminal, and then we can say that D2 is on. If VD2 is coming negative, then we will conclude that D2 is off. Okay, so let us check the voltage VD2, find the voltage VD2 and find the current ID1. That is our objective now. Okay, now how to calculate this? Now by the blue color pen, this is an open circuit path. How much current will flow in this circuit here? Zero current will flow. If zero current will flow, what is the voltage drop across 10 kilo ohm? 0 volt. Okay. Now how much voltage we are having at P terminal? 4 volt. 4. Now this voltage drop is 0. Now let us take this voltage as Vx. Okay. How much Vx we are having? 10. So remove Vx. Just write 10 volt here only. Just we can write 10 volt. 10. This is the 10 volt we are having here. Okay. 10 volt we are having. Now this is 10 volt. This is 4 volt. And 0 voltage drop across this 10 kilo ohm resistance. Why 0 voltage drop? Current is 0 in the open circuited path. Now what is the N terminal voltage now? Directly this 10 volt will come here. Okay. Now calculate VD2. How much VD2 we will get? VD2 is P terminal voltage minus N terminal voltage. 4 minus 10, that is minus 6 volt. If VD2 is minus 6 volt, what is the meaning of this? What is the meaning of this? Diode voltage less than 0 in the ideal diode. P terminal voltage less and N terminal voltage higher. Diode is off condition. Diode is in off condition. Are you getting it or not? Yes or no? Now condition of diode D1 we will calculate. We will investigate condition of diode D1. Here current is going 0 in this branch. What is current in this branch? What is the current in this branch? Let us suppose Ix. This is ground. What is Ix? What is Ix? 10 minus 0 upon 20 kilo ohm. 10 minus 0 upon 20 kilo ohm. How much? 0.5 milliampere. Yes or no? 0.5 milliampere current is flowing in this branch. This branch current is 0. This branch current is 0. This branch current is 0.5. Now how much current is coming from here? What is the ID1 now? ID1 will be equal to Ix only. So now ID1 is equal to Ix only. That is equal to 0.5 milliampere. And this ID1 we have assumed in P to N direction and it is coming positive. What is the meaning of this? When current is going in P to N direction, D1 is really on. What you assumed and what you are getting? You have assumed D1 on, D2 off, and really after investigation we are getting D1 on and this D2 off we are getting. Meaning is that our assumption of D1 on, D2 off is correct. Meaning is that our assumption is correct. If your assumption is correct, my dear friend, if your assumption is correct, what is the meaning of that? This circuit is a perfect representation of this circuit. What is the meaning of assumption correct? Meaning is that in this circuit really D1 is on and D2 is off. Meaning is that this circuit and this circuit are equivalent to each other. And now we will calculate the required answer. We have to calculate this node voltage V0. This V0 we have to find out. Our assumption is correct, means this circuit is correct. Meaning is that this circuit is correct circuit. Okay, now what is V0? Complete voltage across this 20 kilo ohm is 10 volt. So how much voltage? 10 kilo ohm, 10 kilo ohm. Same current is there. Series 2 resistance are there. How much voltage drop will be across this 10 kilo ohm? Half voltage will be divided. Hence V0 will be equal to how much? You can write on the next page. Okay, what is the V0 now? V0, how much you can calculate? This is the condition we are having. Okay, this is 10 kilo ohm resistor. This is again 10 kilo ohm resistor. This is ground. This V0 you have to find out. And this node voltage you are having 10 volt. How much V0 you will get? How much V0 you will get? What is V0? 10 into 10k, voltage divider rule. What is voltage divider rule? Complete voltage into resistance upon total resistance. 10 into 10k upon 10k plus 10k, 20k. How much voltage? 5 volt. So V0 is equal to 5 volt is the answer. Very simple problems, dear friend. You can solve these questions very easily. Are you getting it? Very simple problems. Now we will go for next question. Now we will go for next question. Now we will go for next question. Yes or no? Yes or no? Yes. Now go to next question. What is the next question? Question number 3rd. Give the answer question number 3rd. Okay. Yes or no? Let us take question number 3. Question number 3. D1 diode is there. Diode D2 is there. 10 volt is here. Minus 10 volt is here. 10 ohm is here. 5 ohm is here. Ideal diode is there. Okay. Find the value of V0. Find the value of V0. Meaning is that again in this question, first of all, we have to find out the condition of diode D1 and D2. How to investigate condition of D1 and D2? Yes or no? Condition of D1 and D2. How to investigate? Okay. So now take D1 and D2 condition. What is the condition of D1 and D2? Let us assume. What do you want to assume? Now assume randomly. Now just first of all check which condition is most probable in the circuit. This is a 10 volt connected at the P terminal of the diode, and the N terminal of the diode is connected with the minus 10 volt battery, or either by ground terminal if D1 is on. If D1 is on, this terminal voltage will be 0. Okay, so D2 anyhow will be on in this circuit because P terminal is connected with the 10 volt and N terminal of the D2 may be connected with the minus 10 volt, or maybe we can say connected with the 0 volt. So N terminal is having low voltage, P terminal is having high voltage, meaning is that D2 is 100% will be on in this circuit. Now what you can assume for the condition for the diode D1? D1 is having 0 voltage at the P terminal, and we don't know what is the N terminal voltage. Let us assume whatever you want to assume. What do you want to assume? Let us assume randomly. I am assuming what I am assuming. What I am assuming. Okay. What I am assuming that D1 off. Let us take D1 off because this condition will come false definitely. Okay. Let us take D1 is off. Okay. Let us take D1 is off. Okay. Now D1 off, D2 on. Check it. Solve it. That is 10 volt. D1 off, D2 on. D2 on, ideal diode, short circuit. Current, take current ID2 from P to N direction. Current ID2. This is 10 ohm resistor. 10 ohm resistor. This is 5 ohm resistor. This is minus 10 volt battery. V0. We will calculate V0 in the last. Okay. First of all, condition of the diode and D1. Diode D1 and D2 we must investigate. Okay. Now D1 we are assuming off. Let us take off diode. Now in the off diode open circuit, what we can measure? We can measure voltage VD1. Yes or no? Now how to solve it? How to solve it? This diode D1 you have assumed off. current is 0 from here. Okay, 0 current is flowing, but we have to investigate its voltage VD1. Now suppose this current ID1 is flowing, this complete current ID2 will go like this, like this, like this, because there is open circuit path. Now how much ID2 you will get? 10 plus 10. See, what is the meaning of this 10? This is the meaning of this 10 voltage, yes or no? Minus 10 volt. What is the meaning of this minus 10 volt? What is the meaning of this minus 10 volt? This is the meaning of this minus 10 volt battery, yes or no? So how to apply, how to find this current ID2? Plus 10 volt divided by how much? How much? 10 plus 5, 15 ohm. How much ID2 you will get? 20 upon 15. What is the meaning of 20 upon 15? 4 by 3 ampere. Now 4 by 3 ampere current is flowing. Okay. This current is greater than 0. P2 and direction current is flowing. Really D2 is on. Okay. Our assumption of D2 on is correct. Okay. But what is the state of D1 now? D1 state we can investigate by calculating its voltage. This voltage 0. But we have to find out this voltage Vx. How to calculate this voltage Vx? Now how to calculate 10 minus voltage drop across this 10 ohm. So how much Vx you will get? 10 minus voltage drop across this 10 ohm. Like and share and subscribe. This is the must condition. Subscribe and share maximum to your friends so that maximum student can get benefit from this crash course. What is the voltage drop across this 10 ohm? 10 multiplied by 4 by 3. Yes or no? What is the answer for Vx? 40 by 3, that is 30 minus 40 upon 3, that is minus 10 by 3. Yes or no? Now Vx is minus 10 by 3. What is VD1? What is VD1 now? What is VD1? VD1 is P terminal voltage minus N terminal voltage. 0 minus Vx. 0 minus Vx. What is 0? 0 minus. What is Vx? Minus 10 by 3. Put minus 10 by 3. Yes or no? Yes or no? Okay. Yes or no? This is 10 by 3. This is 10 by 3. Yes or no? I am live beta. I am live. Okay. VD1 is 10 by 3 volt. What is the meaning of this? It is greater than 0. P terminal is having positive potential with respect to N terminal. What is the meaning of that? D1 is on. What you assumed earlier? You assumed D1 to be off. But the voltage across the D1 is coming positive. Meaning is that D1 is on, dear friends. So what is the meaning of that? In this question, D1 is on and D2 is also on. Your assumption is wrong. Our assumption is wrong. If our assumption is wrong, what is the meaning of this? What is the meaning of this? This circuit is not representing exactly the given circuit. Given circuit and this circuit are not equivalent circuit because our assumption is wrong. What is the exact condition? What is the exact condition in the circuit? D1 on and D2 on. So now we have to draw the circuit again by considering D1 on and D2 on. Now consider D1 and D2 on, both are on, and then redraw the circuit. Circuit will be like this. Circuit will be like this, my dear friends. Circuit will be like this. Circuit, okay? Circuit will be like this. This is 10 volt battery, okay? And both the diodes are on. This diode is on. That is our D2, diode D2, and this is the current ID2. Some resistance we are having here. Some resistance is here. Some resistance is here. And here we are having minus 10 volt battery. And here we are having some resistance. Okay. One resistance is 10 ohm. This is 5 ohm. This is 10 ohm. And this is 5 ohm. Now here D1 is on, short circuit 8, and this is ground terminal. Now what is the question? Find the value of this node voltage V0. This node voltage V0 we have to find out. What is the answer for this? What is the answer for this? D1, D2 both are on in this case, in this circuit, and we have assumed on. Now calculate the voltage V0. This is ground, 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 ground. V0 equal to 0 volt is your correct answer for this question. Are you getting it? So always think like that. If your assumption is going to be correct, definitely you are saving your time. We are saving our time if our assumption is going correct in any given question, because when our assumption is going wrong, we have to redraw the circuit again and then we have to calculate. That's why always think like that. Assume the condition that you are feeling most probable in the circuit. Are you getting it? Now let us go for the next question. What is the next question? Cut-in voltage V gamma of the diode is given. Cut-in voltage V gamma is given. Meaning is that now don't consider diode to be ideal. Meaning is that whenever you think diode is on, you have to replace diode by a cut-in voltage V gamma battery. Are you getting it? Now in this circuit, two diodes again we are having, and all the voltages are the DC voltage. We have to calculate V1, V2. What I told you, V1, V2 is secondary things. First of all, we have to identify condition of diode D1 and D2, whether diode D1 is on or off. That we have to investigate first. Meaning is that now in this circuit what we have to do is, this is the 3 volt, this is 6 volt, this is 6 volt. What is the condition of D2 and D1? We have to investigate. Now suppose you are not having any feelings. Suppose you are not having any feelings for any diode to be on or off. Just assume randomly what you want to assume. Okay. What you want to assume, just assume randomly. Suppose assume both diodes are off. Suppose assume D1 off, D2 off. Assume both diodes are off. Assume let both are off, D1 off, D2 off. If you are assuming D1 off, D2 off, you have to investigate by drawing the equivalent circuit whether this condition is correct or not. Okay, now see, this is a 6 volt battery. Okay, this is a 6 volt battery, and this is again a 6 volt battery. Okay, now this is a resistor, this is a diode, and this is a diode, and this is again a resistor, and this is a battery. Okay, 6 volt battery. Here we are having some 3 volt battery. Here we are having 10 kilo ohm resistor, and here we are having diode, and here we are having 10 kilo ohm again resistance. Okay, here we are having some diode, again diode we are having. Now this is a 6 volt battery. Now let us assume both diodes are off. If both diodes are off, you are assuming just open circuited it. Now calculate the voltage across D2, that is P side, this is N side. This is P side and this is N side. This is diode VD1. Okay, sorry, this is P side, left side is P and right side is N. Meaning is that this is a diode voltage VD1, my dear friend. Now find out these two voltages, then your life will be simple definitely. Now how to calculate these voltage? This circuit is open. What is the current? 0 ampere. This is open, current is 0. Current is 0 at this node. Both two currents are coming 0. Definitely this current is also 0. If this current is 0, how much this node voltage will come? Because this voltage drop is 0, this node voltage will be 3 volt. Okay. What is this voltage will come? Current is 0. 0 voltage drop is there. How much this voltage will come? How much this voltage will come? 6 volt will come definitely directly. Now calculate VD2. How much VD2 you are getting? VD2 is 3 minus 6. 3 minus 6 minus 3 volt. Reverse bias less than 0. So meaning is that D2 is coming off. Yes or no? Your assumption is going to be correct for the D2. But what is the condition of D1? This is 3 volt. This is 6 volt. If you calculate VD1, how much? 6 minus 3, that is 3 volt. It is coming greater than, sorry, we are comparing it with the V gamma. Cut-in voltage given. Cut-in voltage given. Always compare with the cut-in voltage. So V gamma is 0.6 and this VD2 is coming less than 0.6. That means D2 is off. Yes or no? Now VD1 is coming 6 minus 3, that is 3 volt, and this 3 volt is greater than V gamma diode cut-in voltage. Meaning is that D1 is on, beta. D1 is on, my friends. Okay. Now D1 is on, D2 is off. You are assuming, you assumed D1 to be off, but it is coming on. Meaning is that our assumption is wrong, my friend. Your assumption is wrong. So now what is the condition? If your assumption is wrong, definitely your time is killing. D1 on and D2 is off. This is the true condition of this circuit. This is the true condition of this circuit. D1 on, D2 off. Yes or no? D1 on, D2 off. Now let us take D1 on and D2 off. In this circuit, D1 on, D2 off, and then calculate B1 and B2. That will be the correct answer. Can you say this B1 is this node voltage, this B1 equal to 6 volt and B2 equal to 3 volt? Is it correct? No, it is not correct, because this circuit is not a perfect exact representation of this circuit. No, it is not representing this circuit exactly, because both are not equivalent, because your assumption is wrong. That's why this assumption, after checking that assumption, we are getting this condition. What is the meaning of that? For this condition, we have to redraw the circuit, and then we have to calculate V1 and V2. That will be the correct answer for this circuit. So now calculate V1 and V2. Now you will see D1 is on and D2 is off. How to calculate now any calculations? Okay, so now this is the 6 volt battery. This is a 6 volt, and downside is a 3 volt battery. Okay, 3 volt battery. And this is the resistor, this is the resistor, this is the diode. Okay, and again this is the diode, and this is the 6 volt battery. Okay, so this is the 6 volt battery. Okay, now what is coming? D1 is coming on, D1 is on, and diode cut-in voltage is 0.6. Replace D1 by 0.6 battery. Okay, 0.6 battery. Now what is there? Here we are having some diode. Okay, that diode D2 we are assuming that D2 is coming off. Okay, here we are having some resistor. Of how much value? Any value, that is 10 kilo ohm, doesn't matter. And this is the voltage that we have to investigate. Okay, that is V1, and this is the voltage V2 that we have to investigate. Okay, these two voltage we have to find out, and this is the D2 diode that is off, and this is the resistance of 10 kilo ohm. That is the perfect representation of the circuit. Now what is the answer for V2 and V1? Now we will give the answer. Here current is 0, open circuit path, current is 0, voltage drop is 0. Now if this voltage drop is 0, this 6 is coming directly. So V1 will be equal to 6 volt, and this V2 will be, this is 6 minus 0.6. How much V2 you will get? This node voltage is 6 minus 0.6. What is the answer? 5.4 volt is the answer for this V2 value. Yes or no? So now these are the correct answer. V1 is 6, V2 is 5.4. Meaning is that if suppose you are giving the answer V1 equal to 6, V2 equal to 3 volt, that will be the wrong answer. Are you getting it? So correct answer is this. Now let us go for next problem. This is the question. Okay, this is the previous year gate question. The diode in the circuit given below has cut-in voltage V on equal to 0.7, but is ideal otherwise. The current in milliampere in the 4 kilo ohm resistor is. Here 4 kilo ohm resistor is where? Here we are having this 4 kilo ohm resistor. In this 4 kilo ohm resistor, we have to find out the value of current that is flowing. Okay, how to calculate this current flowing through this 4 kilo ohm resistor? Just by checking the first the status of the diode, whether diode is on in this circuit or whether diode is off in this circuit. First we have to investigate that. Okay, so meaning is that how to solve it? First of all, this is just a bridge, is nothing but a bridge whose one arm is having 2 kilo ohm, opposite arm is having 6 kilo ohm. Okay, another arm is having 3 kilo ohm and opposite arm is having 4 kilo ohm. It is a balanced bridge, my dear friend. 2 into 6 kilo ohm, 2 kilo ohm into 6 kilo ohm is equal to 3 into 4 kilo ohm, 3 kilo ohm into 4 kilo ohm. It is a balanced bridge. 6 into 2 is 12. That is equal to 12. It is a balanced bridge condition. Balanced bridge it is. Yes or no? If it is a balanced bridge, If it is a balanced bridge, what is the meaning of balanced bridge? If any bridge is balanced bridge, then current flowing in this branch is always zero. Current flowing in this branch is zero. Zero current will flow in this branch. If zero current is flowing in this branch, what is the meaning of that? This diode D will be off. When a diode current is zero, what is the meaning of diode? Diode is off. Balance bridge is there. Diode current will be zero. That's why diode current will be zero. Meaning is that in this circuit, definitely this diode is off. If diode is off, how this circuit will be replaced? How this circuit will be replaced? This circuit is replaced like this. The circuit will be replaced by this. Okay, this is the circuit replacement. Now see, this is the current source. This is the current source of 1 milliampere. Okay, we are having 4 resistor, 1, 2, 3 and 4. 4 resistance we are having. These are the 4 resistance that we can have in the circuit, that is 2 kilo ohm, 4 kilo ohm, 6 kilo ohm and this is 3 kilo ohm. 4 resistors are there. Now what is the question? Question is this. Calculate the current flowing through the 4 kilo ohm resistor in milliampere. This is our objective, okay, of calculation. How to calculate? 2 kilo ohm and 4 kilo ohm both are having same current, both are in series, and this 3 kilo ohm and this 6 kilo ohm will have same current because both are in the series. Current division rule, my dear friends. This is a total resistance we are having. How much? 2 plus 4 6. This total resistance how much we are having? 3 plus 6 9k. How to calculate this current I in 4 kilo ohm? What is the current now? What is the current? Current division rule. Now let us draw first once again. What is the equivalent of this? Okay. Oh, no need to draw the equivalent. Okay. So, okay, I am drawing. Okay. For your simplicity, I am drawing it. Okay. So that you can understand it clearly. Very clearly you can understand. Okay. So what is the resistance? 4 kilo ohm, through which we have to calculate the current. Okay. 2 resistors are there. Okay. Now connect these resistance. Series combination of this is 6 kilo ohm. Series combination of this is 9 kilo ohm. What is the I that we have to calculate? 4 kilo ohm resistors current. Meaning is that 2 kilo ohm resistor current. Meaning is that this 6 kilo ohm resistors current. 6 and 9 are in parallel. 6k, 9k, 6k, 9k. And this is the 1 milliampere current. And we want to calculate current in this 6 kilo ohm. What is the current division rule says? Current I equal to total current 1 milliampere into 9 kilo ohm resistor divided by 9k plus 6k. That means 1 milliampere into 9 upon 15. What is the answer? 3335. Yes or no? 0.6 milliampere is the answer for this question. Are you getting it? How much is the answer? 0.6 milliampere. Yes or no? 0.6 milliampere is the answer for this question. Now let us go for the next question. This is the next question. Okay. This is the next question we are having. This is the next question. What is the problem? What is the problem in this question? A battery is given, one resistor is given and one diode is given, no doubt. Okay. Now I current across this diode is V minus 0.7 upon 500 ampere when voltage across the diode is greater than equal to 0.7 volt, that is mentioned. And this current I flowing through this diode is equal to 0 when voltage across the diode is less than 0.7 volt. Find the I in the current, I in the circuit. This is the third case of the diode model. First case is ideal diode, short circuit, open circuit. Second is diode, second model is replace diode by the cut-in voltage V gamma, and in the open circuit case just open circuit in the off case. Okay. Now third case is diode, if diode is off, replace it open circuited, means current is 0. And if diode is on, replace diode by the V gamma battery and resistance. What is the meaning of this? What is the meaning of this? Let us investigate first. Suppose we are having any diode. Suppose we are having any diode. What is the meaning of this? Now we will investigate. Suppose we are having any diode whose voltage is V and current flowing through it is I, is replaced by, suppose, third model. What is the third model? Third model is saying that we can replace the diode by its cut-in voltage, and in series with we will have some resistor. Okay, that is the RF. And we are replacing the diode by its cut-in voltage, that is V gamma. Okay, that is V gamma. Now this is the P terminal of the diode, this is the N terminal of the diode. This is P and this is N. What is the complete voltage across the diode is V. What is complete diode? This is the complete diode. This is the complete diode. This is nothing but, what is? It is nothing but a diode, my dear friends. Diode complete voltage V. That's why this complete voltage V. What is the current flowing in the diode from P to N? I. This current is I. Now apply the KVL, my dear friends. Now apply the KVL. Plus V minus V gamma minus I into RF. You will get equal to 0. Now how much I you will get? I will be V minus V gamma divided by RF. What is the meaning of this? Current flowing through the diode when we are assuming diode to be on is equal to V minus V gamma upon RF. When it will come? This current will come when this total voltage across the diode is greater than V gamma. Then only this diode will be on. Otherwise this current will be 0 when V is less than V gamma. Because the voltage across the diode is less than cut-in voltage, diode current will be 0 because diode is replaced by the open circuited. So this is the condition. Now in the same way it is given here. Same way it is given here. I is equal to some total voltage of the diode V minus 0.7. What is the meaning of this? In this circuit V gamma is 0.7 volt diode cut-in voltage. Divide by RF. What is the meaning of that RF? How much RF is there? Here we are having 500. Hence RF is 500. Now what is the unit of RF? RF can have unit of ohm, milliohm, or ohm, kilo ohm. See, current is in the ampere. Whenever current is in the ampere, resistor will be in the ohm. Whenever current is in the milliampere, resistor will be in the kilo ohm. So this is the 500 ohm resistor RF. Okay. So RF we know, V gamma we know. We can solve this problem now. How to solve? See, here 10 volt battery is connected across the diode. Diode cut-in voltage 0.7. Definitely diode will be on due to this 10 volt battery. Due to this 10 volt battery, diode will be on in this circuit. Diode cut-in voltage is only 0.7 and this 10 volt battery is connected across this, diode will be on. That's why, what is the equivalent of this circuit now? Diode will be on. This is the 10 volt and we are having some resistance of 1 kilo ohm. Some resistance of 1 kilo ohm, and now diode is replaced by cut-in voltage V gamma and resistance RF. RF resistance and cut-in voltage V gamma. It will be replaced. Okay. Now V gamma is how much? 0.7 volt. RF is how much? 500 ohm. Some current that is flowing that we have to calculate. This current we have to calculate. This current we have to find out. Now you can find out how much current will flow in the circuit. I will be 10 minus 0.7. This is the 10 volt minus 0.7 upon 1k plus 500. What is the meaning of 1k? 1000 ohm plus 500. What is the meaning of this? 9.3 upon 1500, and this is the ampere, or in the milliampere we can write 9.3 divided by, if we write 1.5 kilo ohm, then we can have current in the milliampere. So that is the answer. Okay. Okay. So this is the answer of the current in this circuit. I is equal to 9.3 upon 1.5 milliampere. This current is flowing in the circuit. Okay. 6.2 milliampere. You will get the answer. Okay. Now go for the clipper circuit. Okay. Now go for the clipper circuit. Diode with respect to DC, we have solved some problems. Okay. So in this crash course, we will discuss all the points, all the concept that is possible for the diode circuit, possible for the BJT, possible for the MOSFET, possible for the op amp. So we will cover complete syllabus so that it can help you in the GATE examination much. Yes or no? Much and more number of question you can solve in the GATE examination. That is our objective. Okay, that is the objective of this crash course, so that you can solve as many number of problem in a short duration of time and you can score maximum marks in the GATE examination if you are not started any preparation right now. And if you are preparing from now only, then it is very much useful. Or those who have completed the syllabus and now they want to revise the subject, then it is a good strategy to revise the subject. So it is for the revision as well as for the students who are preparing only from now onward. Okay, so it will be helpful. So it will reduce their burden. Crash course always reduce the burden. Okay, now okay now this is the diode, this is a 2-volt battery, this is the resistor R. Now this is the input waveform we are having, this is the input waveform we are having Vin, and this is the input sinusoidal signal is applied here. Now this is the Kilper circuit. How to identify the Kilper circuit? The identification of Kilper circuit is very simple. We are having some AC signal whose amplitude is very large, like that 5 sin omega t volt, 10 sin omega t volt, 15 sin omega t volt, like that we are having a sinusoidal wave. Okay, and some DC voltage, reference voltage we are having in the circuit, then it is a Kilper circuit. Kilper circuit means it will clip off some portion of the input signal and retain the remaining signal at the output. That is known as the Kilper circuit. Now we will investigate this circuit, how to proceed these types of circuit very easily. Okay, no information is given about the diode. Consider diode is ideal. Consider diode is ideal. Okay. Okay, now see, this is the Vin, this is the diode, this is the R, this is 2 volt. Now this N terminal is having some 2 volt and this P terminal is connected with the input power supply Vin. Okay, so now when input voltage is less than 2 volt, diode will be off. When input is less than 2 volt, what is the condition of diode? What is the condition of diode in this circuit? When input is less than 2 volt, diode will be off. Okay, diode is off. Okay, diode is off when input is greater than 2 volt. Okay, and so when diode is off, what is the answer? If in the circuit, if diode is off, diode will be open circuited and circuit will become like this. Yes or no? And this is the 2 volt battery. Okay, now this is the input voltage Vin. Now what is the output voltage V0 you will get? Since this diode is off, what is the current in the circuit? 0 ampere. Hence voltage drop across the resistor is 0 volt. Now this is a 2 volt, 2 volt, 2 volt. Complete 2 volt will come across the output. Output will be equal to 2 volt. Yes or no? Now second case is when Vin is greater than 2 volt, what will happen in the circuit? Okay, now suppose Vin is greater than 2 volt. When Vin is greater than 2 volt, suppose Vin is 3 volt and this is the diode. P terminal is having 3 volt and N terminal is connected with the 2 volt battery. P terminal voltage is higher than N terminal voltage. Diode will become on. Diode is on. Now if diode is on, diode is ideal given in the circuit. Hence what we have to do is replace diode by the short circuit path. My dear friends, we will replace the diode by short circuit path. Okay, this is the short circuit path. Now what is here? Resistor is there, some battery is there. Please like and subscribe as much as possible so that maximum student can get benefit from it. And we are having 4 lecture per day, each lecture for the 2 hours. Okay, digital, analog circuit, mathematics and electrical machine. These much of subject we are discussing. Okay, so this is the output voltage V0. How much V0 you will get? What is the voltage drop across the resistance R? We don't know because R is unknown. Now see, completely this Vin, this is the Vin, this is the Vin. Vin is coming like this. What is the output voltage now? if we apply KVL in complete outwards loop, that is plus V in minus V naught equal to 0, V naught will be equal to V in only. Output voltage V in only. Meaning is that what you are getting in the circuit, V naught will be equal to 2 volt as well as V naught equal to V in you are getting. Now you can draw the waveform. How you can draw the waveform? This is the input waveform we are having. Now input voltage comparing with the 2 volt, reference voltage 2 volt. When input voltage greater than 2 volt, output equal to something 2 volt. When input is greater than 2 volt, output voltage coming equal to input voltage. What is the meaning of that? Input voltage being compared with the 2 volt reference voltage. So now let us take 2 volt reference voltage, 2 volt reference. This is the 2 volt reference. Okay, this is the 2 volt reference we are having. Yes or no? What is the meaning of that? We have to compare input voltage with this 2 volt battery. We have to compare input voltage with this 2 volt battery. When? See beta. When input voltage is less than 2 volt, what we are observing? When input is less than 2 volt, B naught will be equal to 2 volt only. So in this case, B naught is coming equal to 2 volt. Now, when input is going above the 2 volt, in this portion of the input signal, input is going beyond or above 2 volt. When input is going beyond or above the 2 volt, output will follow the input voltage. Input voltage sinusoidal. Follow it, follow it, follow it. Now, when input is going again down, input is less than 2 volt. When input is less than 2 volt, again V naught is coming equal to 2 volt. V naught is again coming equal to 2 volt. This is the 2 volt. Now again input voltage is greater than 2 volt, then V naught equal to V in. In this range, input is again going above the 2 volt. Hence V naught will follow V in. What is the meaning of this? What is the output waveform you are getting? Output waveform is this red one. This red one plot. This red one plot is this. Meaning is that in the output you are getting this kind of waveform. Okay. This is the output waveform you are observing. So is it exactly as of input signal? No. It is the clipped version of the input signal. Lower portion of the input signal is clipped off. Below 2 volt level of the input signal is clipped off, and above 2 volt level of the input signal is being passed through the circuit. That's why it is known as clipper. So this is the output waveform we have drawn. One more important discussion of clipper circuit is its transfer characteristics. What is the transfer characteristics of the clipper circuit? Let us see. Transfer characteristics of any device in this bulb, any circuit in this bulb is always drawn between output voltage and input voltage, or we can say transfer characteristics is always drawn between output and input. Okay, now what are the possible output we are getting in this question? What is the V naught equal to V in we are getting? What is the meaning of V naught equal to V in? At xy plot, y equal to x means a linear line. Meaning is that V naught equal to V in is a straight line. So now let us draw the straight line V naught equal to V in. This is the straight line that we can have. Okay, that we can have, that is V naught equal to V in. First line we are having in this circuit. Now what is the second condition? V naught equal to 2 volt is the second condition. So let us draw V naught equal to 2 volt as well. That is the V naught equal to 2 volt we are drawing. Okay, so now V naught equal to 2 volt. Now dash. Okay, draw it by dash line dash. Okay, that we are having. Okay, no problem. Now this is V naught equal to V in. This is V naught equal to 2 volt. Now what is this intersection point of these two lines? What is the intersection point? Now solve these equation. V naught equal to V in and V naught equal to 2. Put this V naught equal to 2 in this equation. Equation 1 and 2. What is the solution of this? V naught equal to V in. Put V naught equal to 2 volt equal to V in. V in equal to 2 volt. You will get some point. Okay. On this axis. On this axis, I am getting some point V in equal to 2 volt. I am getting some point V in equal to 2 volt. Okay, 2 volt. What is the meaning of this? What is the meaning of this? Meaning is that at 2 volt, both the equations of both the lines are touching each other. Meaning is that when V in voltage is greater than 2 volt, either this line will be correct or this line will be correct. When V in is less than 2 volt, output will follow either this line or either this line. Now you can check very easily. When V in is greater than 2 volt, when V in is greater than 2 volt, V naught equal to V in. V naught is equal to V in. Okay. So when V in is greater than 2 volt, V naught is following V in. So V naught equal to V in is the correct answer. Okay. Now, when V in is less than 2 volt, diode is off, V naught will be equal to 2 volt. So when V in is less than 2 volt, V naught equal to 2 volt. So let us draw this line. By a dark pen we are drawing. Okay. This is the transfer characteristics. This is the transfer characteristics. And this point, that comparison point or reference point, is known as break point. We can say this is break point. Okay. So meaning is that when V in is less than 2 volt, something else is happening in the circuit. When V in is greater than 2 volt, something else is going on in the circuit. Okay. So this is known as transfer characteristics. Here we can write it is the transfer characteristics of this clipper circuit. Transfer characteristics of this clipper circuit is this. Transfer characteristics. This is the transfer characteristics. Okay. This is the transfer characteristics. Any problem in this question? Any problem? Do you have any problem? Okay. Okay. Now we will go for next question. Okay. We will go for next question. Before that, if someone asks you what is the voltage drop across the resistance R, that you can also calculate. When diode is off, voltage drop across the resistance R is 0. Or when diode is on, what is the voltage drop across resistance R is V in minus 2 volt. V in minus 2 volt is the voltage drop across resistance R. So you can calculate the value of voltage across the resistance R in both the conditions. Now go for the next question. Very similar to previous only. Okay. After that we will go for some difficult problem as well. Okay. This is the question. Okay. In this question, what is given? Some resistance R is given, some diode is given, and 2 volt battery is given. Now 2 volt battery is nothing but minus 2 volt battery is given, and this battery, this 2 volt is making diode reverse bias. It is providing 2 volt reverse bias because P is connected with the negative terminal of the battery. So it is providing reverse bias to the diode, and this is the resistor R. Now what we can do is, in this circuit we will compare input voltage by minus 2 volt with minus 2 volt. So now compare, because one terminal N terminal is connected with the input signal and P terminal is connected with the minus 2 volt. Okay. So now compare with minus 2 volt. When input voltage greater than minus 2 volt, what will happen in the circuit? Let us see in this question. Many of the students get confused in this question, this type of question, when polarity of battery is changed. Okay. Now, when V in is greater than minus 2 volt, what is the meaning of V in greater than minus 2 volt? What is the meaning of that? When V in is greater than minus 2 volt, V in may be minus 1 volt, V in may be 0, V in may be plus 1, V in may be plus 2, V in may be plus 5. Suppose V in is plus 5, 5, 5, 5, 5. N terminal is having 5 volt and P terminal is having minus 2 volt. Which is higher? This is 5 volt and this is minus 2 volt. Current will go from N to P direction. N to P direction current means diode is off. Diode is off. So when V in is greater than minus 2 volt, diode will be off in this circuit. Okay. When diode is off in this circuit, this is the resistance R and this diode is off and this is the minus 2 volt battery. Yes or no? And this is the power supply voltage V in. This is the power supply voltage V in. Are you getting it? Now how much V naught we will get? How much V naught we will get? Don't do any mistake in the calculation of the networks. Okay. What is the current in the circuit now? Zero current will flow because this is the open circuit. Now zero current is flowing. What is the voltage drop across the resistance R? 0 volt. Now what is this V naught? V in minus 0. V in, 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 no drop. V in, V in, V in, V in. V naught will be equal to V in only input voltage. Okay, now let us take second condition. Let us take second condition when V in is less than minus 2 volt. V in is less than minus 2 volt. What is the meaning of that? Less than minus 2 volt, V in is minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, like that. Suppose V in is equal to minus 5 volt. Here is minus 5, here is minus 2. Which is higher potential, minus 2 or minus 5? Current can flow from minus 2 to minus 5, P to N direction. Meaning is that diode will become on. Or we know very well, for this condition, if diode is off, definitely for the reverse condition, and for the reverse case, diode will be on definitely. Yes or no? So now diode is on. Okay, I am erasing it. Okay, no problem. So now diode is on. Now if diode is on, just redraw the circuit, equivalent circuit. This is the R. Diode is on. This is the diode on. This is minus. This is plus. And this is 2 volt. Okay. Now let us see. Okay. Are you enjoying the guys? Okay. Just I want very much like from you and hearts in the comment section. Many hearts, as many as possible. This red color hearts I want. Okay. This I want from you. Yes or no? How much you love me, that it will show. Okay. This red color heart I want from you. Okay. Now this is input signal V in. This is the input signal V in. And this is the output voltage V naught. Yes or no? A diode is on in this condition. This is short circuited. Now how much V naught you will get? How much V naught you will get? V naught will be equal to minus 2 volt you will get. V naught equal to minus 2 volt we are getting. Now we can draw the characteristics or output waveform as well. This is the input waveform of the signal. Okay, input signal is given this. Now we are comparing input signal with minus 2 volt or plus 2 volt. We are comparing with the minus 2 volt. So now take minus 2 volt reference. Minus 2 volt reference. Okay. Minus 2 volt. Okay. Minus 2 volt. Okay. So we will just do that. Now see. Draw the output waveform. Red color pen. Okay. When input voltage greater than minus 2 volt, what is V naught? See here, input is greater than minus 2 volt. This is the minus 2 volt line. Input is greater than minus 2 volt. V naught will follow the input. So V naught equal to V in we are drawing. V naught equal to V in we are drawing. Now, in this range, V in is less than minus 2 volt. When V in is less than minus 2 volt, diode is on. V naught equal to minus 2 volt. V naught equal to minus 2 volt. Again in this range, again signal will repeat itself by red color pen. Okay, so this red color waveform is the output waveform. If you want to draw separately, it is coming like this. It is coming like this. Okay, from minus 2 volt to maximum value of the input signal that output is achieving. That is the output waveform in the question. Okay, now we can draw the transfer characteristics of this question. Why transfer characteristic is important? They can ask the transfer characteristic as well. Okay, what is the transfer characteristics? Now draw the transfer characteristics. Transfer characteristics we can draw. Transfer characteristics we can draw for this question. Okay, what is the transfer characteristics now, my dear friends? Let me know. Transfer characteristics is drawn between output voltage V naught and input voltage V in. Yes, very good, very good. Okay, output voltage V naught and input voltage V in between V naught and V in, a characteristic is there that is known as transfer characteristic. What is the possible value of output? Output equal to V in, V naught equal to minus 2 and V naught equal to V in. So now V naught equal to V in, this is the V naught equal to V in line. Okay, V naught equal to V in line, no problem. Now what is the second case of the V naught? V naught equal to minus 2 volt. Where you will draw minus 2 volt, my dear friends? V naught equal to minus 2 volt will be this line. V naught equal to minus 2 volt. Okay, V naught will be equal to minus 2 volt is this line. Now What is this? This is the intersection of these two lines. These two lines intersection point, my dear friends. What is the intersection of two lines? How to calculate? How to calculate? Just put the value of both the equation in each other. Okay, put V naught equal to -2 here. You will get Vn equal to -2 volt. Meaning is that this Vn equal to -2 volt is a break point. Is a break point, my dear friends. What is the meaning of that? When input voltage is greater than -2 volt, one of this line output will be following. When Vn is less than -2 volt, one of these two lines output will be following. Meaning is that, let us check from here. What is given? When Vn is greater than -2 volt, V naught will be equal to Vn. So when input is greater than -2 volt, where input is greater than -2 volt? In this portion, Vn is greater than -2 volt. When Vn is greater than -2 volt, V naught will be equal to Vn. So draw V naught equal to Vn now. V naught equal to Vn line. This is the V naught equal to Vn line when input is greater than 2 volt. Now, when input is less than -2 volt, V naught equal to -2 volt. Input is less than -2 volt, V naught will be equal to -2 volt. So this is the characteristics, transfer characteristic that we can draw from the given circuit calculations. Are you getting it? So this is the transfer characteristics. Any problem? Anyone is having any problem in this? Very simple problem, very simple question is this. Yes or no? Okay, now we will go for next question. There are two diodes we are having. There are two diodes, meaning is that two reference level 3 volt and 7 volt we are having. One diode is T1, one diode is T2, one resistance R is here. We can find out the transfer characteristics and output waveform for this question as well. So this is the difficult question now. Okay, now how to solve? Two diodes are there. So one is 3 volt here, one is 7 volt here. Now how to calculate this? Okay, now 7, 3, how many possibilities are there? Vn greater than 7 volt, we will check. Vn less than 3 volt, we will check. And for Vn greater than 3, less than 7, we will check. Now what we will check? When input voltage is greater than 7 volt, what will happen in this circuit? What is the state of D1 and D2? And what is the output we can have? When input is greater than 7 volt, how much you can take? Suppose let us take, when input is greater than 7 volt, take Vn equal to 15 volt. Suppose Vn is equal to 15. Sir, we are having one confusion. Some resistance is having some drop. Let us take some 1 volt. Okay, let us assume 15 minus 1, 14. Due to this 14 volt, D2 will be on. P terminal is having 14 volt, N terminal is having 7 volt. D2 will be on. Once D2 is on, whether input is greater than 7 volt, once D2 is on, this 7 volt will come here. This 7 volt will come here. And when 7 volt is here, due to this 7 volt at the N terminal, 3 volt at the P terminal, D1 will remain off condition. So meaning is that when D2 is on, 7 volt will come at this node and this 7 volt will make D1 off. So meaning is that what we can say? D1 will be off and D2 will be on. Okay. D1 will be off and D2 will be on. Okay. D1 off, D2 on. Now draw the circuit. Draw the circuit. D1 off, D2 on. Draw the circuit. D1 off, D2 on. Now in the circuit, D1 is off, open circuit. This is the battery. D2 on, just make it on. We will make it on. Okay. And this is the resistance R. Okay. This is the resistance R. And this is the input voltage Vin. This is the input voltage Vin. Now D1 is off, make it open circuited. Okay. This is the 3 volt. Okay. My dear friends, now D2 is on, make it short circuit. Okay, and this is the 7 volt. Now how much V0 you will get? How much V0 you will get? This is the open circuit. Directly it is connected with the 7 volt na. Directly it is connecting with the 7 volt na. So V0 will be equal to 7 volt. So whenever Vin is greater than 7 volt, D1 off, D2 on, V0 will be equal to 7 volt. Now what you will take? Vn less than 3 volt you can take. When Vn is less than 3 volt, let us check. Let me erase this. Okay. Now let us check. When Vn is less than 3 volt, less than 3 means how much? 2, 1, 0. Yes or no? 2, 1, 0, minus 1, minus 2, minus 3, minus 5. Okay. Suppose minus 5 is Vn. Okay. Minus 5, minus 5. Sir, R is having some voltage drop. Okay, let us take some voltage drop is there. But don't think too much about this resistance. Okay. Suppose minus 4 is coming here. Due to this minus 4 volt, check the status of D1. D1 N terminal is connected with minus 4. P terminal is connected with the 3 volt. P terminal 3 volt, N terminal minus 4 volt. Okay, D1 will be on. Okay, beta, D1 will be on. If D1 is on, it will remain minus 4 volt? No. If D1 is on, it will be short circuited. Forcefully this 3 volt will come here. 3. If 3 volt is coming here, N terminal of this diode is having 7 volt, P terminal is having 3 volt, D2 will be off. D2 will be off. Meaning is that what is going on in this circuit? This is going on in this circuit when D1 is on, this node voltage is becoming equal to 3 volt. When D2 is on, this node voltage becoming equal to 7 volt. That is going on. So when D2 is on, 7 volt is coming at this node. When 7 volt is coming at this node, D1 is off. So D1 off, D2 on. When D1 is on, 3 volt is coming on this node. 3 volt, 3 volt, 3 volt. P terminal of D2 is having 3 volt. N terminal is having 7 volt. D2 is off. That's why D1 on, D2 off condition we are having. Okay. Now, draw the circuit again. Draw the circuit. If D1 is on, D1 will be short circuited. And this is the 3 volt. Okay. And D2 is off. D2 will be open circuited. And this is the 7 volt. Okay. This is the 7 volt. Okay. You can cross verify as well, yaar. If you want to cross verify, you can cross verify. Now, what is the V0? What is the V0 that you can expect from here? What is the V0? What is the V0? Can we apply KVL like this? Can we apply KVL like this in this loop? So what is the V0 I am getting? V0 will be equal to 3 volt directly. Now, what is the third condition that we can have? Input is less than 3 is over. Input is greater than 7 is over. Now let us take when input voltage between 3 and 7. When input voltage is above 3 volt and less than 7 volt, then what will happen in the circuit? Then what is the condition of the circuit that we have to observe? Okay. Now, from 3 to 7, suppose some voltage is coming here. Suppose some 5 volt is coming here. Suppose some 5 volt. 3 to 7, between 3 to 7, what is the voltage? Suppose 5 volt is coming here. Suppose 5 volt. D1, N terminal 5, P terminal 3 volt. D1 will be off. Okay. 5. If D1 is off, 5 will return here. Return 5. 5 volt is here at the P terminal of the D2 and N terminal of D2 is having 7 volt. N is 7, P is 5, D2 will be off. Both will be off. Both will be off. My dear friends, both diode will be off when input is between 3 and 7. Both diode will be off. So now both the diodes are off. Both diodes are off. D1 off and D2 is also off. Okay. D1 off, D2 off. Both the diodes are off. Now, if both the diodes are off, draw the equivalent circuit. This is the R. Both the diodes are off. Open circuited it. Okay. Now, what is this voltage? 3 volt is there. Okay. 3 volt is there. Now, again, D2 is off. Okay. How much voltage is there? 7 volt is there. Okay. 7 volt is there. Okay. Now, this is the input voltage Vin. Now, what is the output we will get? What is the output we will get? Yes or no? Now, both the diodes are open circuited. Both the diodes are off. Now, what will happen? What will happen? Current is 0. Current is 0. Both the currents are 0. Now, at this R resistance, how much current will be there now? Here 0 current, here 0, this current is 0, this is 0. Now this current is also 0 ampere. Now this is Vin, 0 ampere meaning is that 0 voltage drop. Vin. So apply KVL in the outer complete loop, you will get V0 equal to Vin only. Okay, so V0 equal to Vin you will get. Now what you can do is in the circuit, draw the output waveform and draw the transfer characteristic. First of all, we will draw the output waveform. Okay, where we are comparing the input voltage we are comparing with the 7 volt and 3 volt. So draw the two levels, 3 volt and 7 volt. Okay, now draw the two levels. Okay, 3 and 7. This is the 3 volt level and this is the 7 volt level. 3 volt and 7 volt level we have drawn. Okay, this is the 7 volt level and this is the 3 volt level. Okay, just do it that. Okay, now let us do. Okay, when input is less than 3 volt, from here to here input is less than 3 volt, V0 is coming equal to 3 volt. Okay, V0 equal to 3 volt. When input is 3 to 7, where is 3 to 7? Oh, 3 to 7. Output is equal to input only. What is the input? This green color line. Output will follow the green color line. Now, input is greater than 7 volt. Here in this portion, input is greater than 7 volt. When input is going beyond the 7 volt, V0 will be equal to 7 volt. This is the 7 volt. Now, again 3 to 7, input is between 3 and 7. Output will be equal to input. Now input is going down below the 3 volt. Vin is less than 3 volt. V0 equal to 3 volt only. Okay. Now again from 3 to 7 output will follow input, and again like that this will go on. Meaning is that the input signal is clipped off from two levels. Above 7 volt complete input signal is removed. Below 3 volt complete input signal is removed. Between 3 and 7, whatever value of the input signal we are having, that is coming in the output. Are you getting it? So that black color pen is nothing but the output waveform, and that green color is nothing but input waveform, my dear friends. Any problem you are having? Any problem? Yes or no? Yes or no? That is the output waveform between 3 and 7. Now draw the transfer characteristics, my dear friends. Okay, now draw the transfer characteristics. This is the transfer characteristics. Transfer characteristics is always drawn between output and input. We can draw here. Okay, we can draw it here. Output characteristics is always drawn between V0 and Vin. Okay, V0 and Vin. Now this is V0. This is V0, okay, and this is Vin. What is the answer? V0 equal to how much? 7, V0 equal to 3 and V0 equal to Vin. Three possible answer of V0 we are having. What is V0 equal to Vin? Okay, that is V0 equal to Vin. Next, V0 equal to 3 volt and V0 equal to 7 volt. These possibilities we are having. Okay, bhaiya. Okay. Dash. Okay, dash. Okay. Now this line is what? V0 equal to Vin line. This line is what? V0 equal to how much? 7 volt. Okay. And this line is what? V0 equal to 3 volt. Okay. Okay. Now, what is the possible breakpoints? What is the possible breakpoint? What is the intersection of these two lines? These two lines are intersecting. Which line? V0 equal to Vin and V0 equal to 3. What is the intersection? Definitely 3 volt will come. Meaning is that when input voltage changing above 3 volt, something change is going on in the circuit. Now here, what is the intersection? V0 equal to Vin, V0 equal to 7. Put V0 equal to 7, you will get Vin equal to 7. Okay. Let us put here. What is the meaning of this? What is the meaning of that? When input is greater than 7 volt, when input is greater than 7 volt, out of these two lines, one is possible. When input is less than 3 volt, out of these two lines, output will follow. When input is between 3 and 7, these two nodes are connected by this single line only. That's why the output will follow V0 equal to Vin only. Otherwise, we know the complete information. From 3 to 7, when input is between 3 and 7, input is between 3 and 7, V0 equal to Vin. What is the line? V0 equal to Vin. This is the line. Draw it. Draw it by the dark pen. Okay. Now, when input is greater than 7 volt, V0 equal to 7 volt. Input is greater than 7 volt, V0 will be equal to 7 volt. V0 will be equal to 7 volt. Okay. Now, when Vin is less than 3 volt, V not equal to 3 volt. When Vin is less than 3 volt, V not equal to 3 volt. V not equal to 3 volt. Let us draw. Okay, this is the transfer characteristics we are having for this circuit. That is from T3 to 7, output is following V not equal to Vn, and when input is greater than 7 volt, output is equal to 7 volt. When input is less than 3 volt, output will be equal to 3 volt. That is the complete idea about the circuit. Now, how they can ask the question in the examination? They can ask the question like that: for what range of input voltage D1 is off, D2 is on? In the circuit, for what range of input D1 off, D2 on? You have to say Vin is greater than 7 volt. For what range of input that D1 is on, D2 is off, you have to say Vin is less than 3 volt. Now, for what range of input both the diodes are off, you have to say when Vin is greater than 3 volt and less than 7 volt. Okay. Next, they can ask for what range of input signal both the diodes are on. Can we have both the diodes on condition? No, we cannot have, because we are having three conditions: D1 off, D2 on, D1 on, D2 off, and both are off. Both are on is not occurring in this circuit. Why? Why it is not occurring in this circuit? Because if two diodes are on, both the diodes are on. If both the diodes are on, this node voltage will become due to this 3 volt battery. This node voltage become 3 volt, and when this diode D2 is also on, this voltage becomes 7 volt. At a single node, how we can have two different voltages? That is nothing but violation of KVL. Meaning is that in this circuit, no condition will exist for which these two diodes can be on simultaneously. Both cannot be on simultaneously in this circuit. Are you getting it? Both diodes cannot be on in this circuit simultaneously because no condition exists. Are you getting it? And it is a violation of KVL if both the diodes are on in this circuit. Are you getting it? What I am saying? Yes or no? Yes or no? So what is the note of this question? What is the note? Note: both diodes on. Both diodes are on simultaneously. It is not possible in this circuit. Not possible in this circuit. Why it is not possible? Because it is a violation of KVL. Violation of KVL. KVL law is going to be violated. That's why it is not possible. Now let us go for the next question. Okay. Now let us go for the next question. Very similar problem. We are having 3 volt battery, diode D1, 7 volt battery, diode D2. Now we are having two resistors R and R. Are you getting it? Now we are having two resistors in this circuit. Are you getting it? Two resistors we are having in this circuit. Now how to solve this problem? Now how to solve this problem? Now how to solve this problem? Okay. Now how to solve this problem? How KVL is violated? Because if 3 volt and 7 volt is there, what is the meaning of KVL? Sum of all the voltage drop equal to 0. 3 minus 7 is not equal to 0. 7 minus 3 is not equal to 0. That's why violation of KVL. Okay. Two battery connected in parallel of different value is not having any meaning. Okay. Is not having any sense. Okay, that's why one diode will be off, one diode will be on. That is the condition in the circuit. Now, how to solve this question? How to solve this problem very easily? How to solve this problem? How to solve? What is the equivalent of this circuit? What is the equivalent of this circuit? All these three branches are in the parallel. All three branches are in the parallel. This D1 3, D2 7 or R. We can shift any branch, any side. Let us shift the branch. Let us shift the branch. This is R. And I am shifting that R here only. Okay. Let us shift the R. Let us shift the R. Okay. This is the R. Now we are having one diode is here. Okay. And one battery is here. 3 volt battery. Okay. Now again second diode is here. and another battery of 7 volt here. Okay, that we are having. Any problem? Okay, now see, how can we solve this problem? By the Thevenin method. By the Thevenin. Okay, by the Thevenin method, just find out the Thevenin equivalent across this terminal A and A dash. Okay, suppose this is a terminal A and A dash. Find out the Thevenin equivalent VTH and RTH. Wow, how to calculate VTH and RTH across any terminal? VTH means this R and R will be in the series for this VIN source, because Thevenin resistance or Thevenin voltage means open circuit voltage. This complete portion will be open circuited, this will be removed from the circuit, and just calculate the voltage here due to this VIN. How much voltage you will get? How much VTH you will get across A and A dash? How much VTH? VIN R. VIN will be divided equally in both. VIN by 2. Now how to calculate RTH here? How to calculate RTH here? RTH will be these input source voltage will be short circuited. To calculate the Thevenin equivalent resistance, switch off the sources. If I switch off these sources, this source will be short circuited and these two R will come in the parallel, that is R by 2. Any problem? So this is the R by 2 resistance we are having and VIN by 2 voltage we are having at this terminal. Now, okay, now see. Now what we can do is, again we can redraw it and we can write like this. What is the VTH and RTH? How to mention? RTH equal to R by 2 and VTH equal to VIN by 2. This circuit is equivalent to this circuit as well. Now, this is the previous question only. This is the previous question only. Yes or no? My dear friends, it is the previous question only. Just like previous question only. Okay, I have replaced the same question in the previous question form. But the meaning is changing. We have to calculate the voltage V0 across this resistance R. Okay, no problem. Now what is the condition of this circuit? This is the voltage VIN by 2. That is nothing but VTH only. So VTH, this is R by 2, no problem. Now this VTH is greater than 7 volt. D2 will be on. Okay, so now the condition of diode D1 and D2 we can identify very easily. What is the condition now? Then we will go for this circuit only. Then we will solve for this circuit definitely. First of all, we will identify first condition. What is the first condition? This circuit we know in the advance from the previous question. What is the circuit? When this VTH is greater than 7 volt. VTH means VIN by 2. When this VTH that is equal to VIN by 2, this is greater than 7 volt. What is happening in the circuit? What is happening in the circuit? What is happening in the circuit? Okay. So when this VTH VIN by 2 is greater than 7 volt, D2 will be on, D1 will be off. Yes or no? Okay, D1 on and D2 off. Okay, D1 off and D2 is on. D1 off, D2 on. Okay, any problem? So D1 is off, D2 is on. Okay, that we know. Okay, now we are not solving. Okay, what is the different meaning of this? VTH equal to VIN by 2 greater than 7. What is the other meaning of this? VIN by 2 is greater than 7. Meaning is that VIN greater than 14 volt. So in this circuit, when VIN is greater than 14 volt, D2 will be on, D1 will be off, because these all the circuits are equivalent to each other. Now second case, this VTH that is equal to VIN by 2 is less than 3 volt. This is less than 3 volt that we have solved earlier only. If this voltage VIN by 2, that is VTH, is less than 3 volt, D1 will be on, D2 will be off. Let us see here. When this voltage VIN, this voltage is less than 3 volt, D1 on, D2 off. Okay. So now this voltage is less than 3 volt, D1 on, D2 off. Okay. Write it. D1 on, D2 off. D1 on and D2 is off. D1 on and D2 is off. Okay, no problem. In this case, or what we can do is VIN by 2 is less than 3. What is the meaning of this? VIN is less than 6 volt. What is the third case? Third case is that is VTH, that is V in by 2. Okay, less than 3 we have taken, greater than 7 we have taken. Now remaining range is 3 volt to 7 volt. 3 volt to 7 volt. Now this voltage between 3 and 7, then what will happen? Third case, that is both the diodes are off. If this voltage is less than 3 and 7 and this voltage is coming 5 volt, 5 volt is between 3 and 7, I told you, then this is the 5 volt, then D1 will be off. If this is a 5 volt at the P terminal of D2, 7 volt at the N terminal of D2, D2 will be off. Both the diodes will be off. Both the diodes will be off. Yes or no? D1 off. Okay, D1 off, D2 off. Both are off. Okay, I will tell each and everything in the last. Okay, each and everything means timing, timing, etc, etc. Okay, now how we can write it in the other form? VTS, that is equal to V in by 2, multiply by 2 both the side, you will get 6 volt less than V in less than 14 volt. For that D1 is off, D2 is off. Okay, both are off. Now we are getting the condition. Now we know very well, when in the circuit D2 is on and D1 is off, what is the answer that we have to calculate? We know 3 conditions are possible in the circuit: D1 off, D2 on, D1 on, D2 off, D1 off, D2 off. These 3 possible conditions are available when V in is greater than 14 volt, when V in is less than 6 volt, when V in is between 6 and 14 volt. Now from this circuit we cannot calculate the output voltage V0 because V0 is the voltage across this resistance R. Now we know in this circuit what is the possibility when D2 on, D1 off. So now what is the answer? When D1 off, D2 on, what you can get? What is the answer? What is the answer you can get? D1 off, D2 on. What is the answer? D1 off, D2 on. When D1 is off, D2 is on. D2 is on means if D2 is on, this 7 volt directly connected this, and V0 will be equal to 7 volt only. Are you getting it? Now second case, when D1 is on, D2 is off in this circuit. Second case, this is possible in this circuit. D1 on and D2 is off. Okay, D2 is off. Okay, D1 is on, D2 is off. If D1 is on, this node voltage will become 3. V0 will be equal to 3 volt. Now what is the third case we are having in this circuit? What is the third case we are having in this circuit? What is the third case? D1 off, D2 off. Both are off. Both are off. We are having third case. If both are off in this circuit, let us off both the diodes. Both the diodes are off means open circuit branch. No meaning of open circuit branch. Circuit will be like this only. R. This is open circuit branch. This is open circuit branch. And this is the input voltage V in we are having. Now what is the output voltage you can have? What is the output voltage? This is the R. This is R. This is R. What is the output? Output will be V in by 2. Are you getting it? Output will be V in by 2. Just put these 3 possible answer in the bracket. Okay, in the green color box I am putting. Okay, now see my dear friends, this is the answer. You can draw the output waveform, you can draw the transfer characteristics. Let us draw the transfer characteristics. What is the transfer characteristics of this question? What is the transfer characteristics for this question? What is the transfer characteristics? Now let us draw the transfer characteristics. What is the answer? V0 equal to V in by 2, V0 equal to 7, V0 equal to 3. Okay, V0 equal to V in by 2 by equal to mx and slope is 1 by 2. Okay, V0 equal to V in by 2, no problem. Next, second answer is V0 equal to V0 equal to 7, V0 equal to 3. V0 equal to 3 and V0 equal to 7. Okay, so this is V0 is equal to V in by 2 and V0 is equal to 7 volt and V0 is equal to 3 volt. That are the possibilities we are having. between output and input characteristics, transfer characteristics. Now draw the transfer characteristics of this question. Transfer characteristics. Okay, transfer characteristics. What is the transfer characteristics of this question? What is the transfer characteristics? Okay, what is the intersection point? This is the intersection point. This is the intersection point. What is this point and what is this point? Let us find out this value. Definitely 6 and 14 will come. Okay, now b not equal to 7 and b not equal to bn by 2. How much you will get after solution of these two? You will get Vn equal to 14 volt. What is the solution of these two? V not equal to 7. Okay, sorry, b not equal to 7 and sorry, v not equal to Vn by 2, this line, and v not equal to 3 volt. What is the solution of these two lines? These two lines solution, Vn equal to 6 volt. Meaning is that this voltage is 6 volt. This line v not equal to Vn and v not equal to 3 solution. B not equal to Vn by 2 and b not equal to 7. What is the solution? Vn will be equal to 14 volt. Okay. Now let us draw the transfer characteristics. What is the transfer characteristics? When Vn is greater than 14 volt, when Vn is greater than 14 volt, D1 of D2 on, D1 of D2 on, B naught will be equal to 7. Okay, draw. This is the transfer characteristics. Okay. When Vn is less than 6 volt, Vn is less than 6 volt, D1 on, D2 off, D1 on, D2 off, B not equal to 3 volt. Okay, draw. Now, when Vn is between 6 and 14, definitely V naught will be equal to Vn by 2. So that is the transfer characteristics that we are having for this question. This is the transfer characteristics. This is the transfer characteristics for this question. Any problem? So very simple problem is this. Okay, very simplified manner we have explained this clipper circuit question. Yes or no? That is the simple way of explaining the capacitor voltage diode clipper questions. Okay, same way we will study in the op-amp as well, op-amp clipper. Okay, anyone is having any problem? Anyone? Now let us move for next question. That is the next question. This is the next question. Okay, this is the homework problem you will solve at home. Okay, this is the homework problem. Let us take it as a homework problem. Okay, let us take it as a homework problem. This is the homework problem. You have to find out this output waveform, output value V naught, 1 to 3 volt, and this is the ground. What is the V naught? And this is again second question. B1, B2, B3, 3 voltages are there. D1, D2, D3, 3 volt diode are there. And this is the output voltage V naught across this resistance R. Draw the output waveform. This is the waveform of B1 is given, B2 is given, B3 is given. V naught waveform is we have to find out. V naught waveform. Draw the waveform of V naught. That is the question that you have to solve. Okay, so this is the homework for you. Okay, and once again I am telling you the timings. Okay, timings of the class. See, Bhima Shankar sir is taking digital electronics from 9 AM to 11 AM. It is for weekend only. Weekend means क्या होता है बेटा? Saturday and Sunday. On each Saturday and Sunday, Bhima Shankar sir will be live on the YouTube, this channel only, from 9 AM to 11 AM for discussion of digital electronics. After that, I will follow the lecture from 12 PM to 2 PM. I will teach you analog circuit. After that, if you are from electrical background, okay, Ankit Goyal sir will teach you 4:30 to 6:30 electrical machine. And after that, धुआंधार बल्लेबाज हमारी टीम के विशाल सोनी सर will teach you engineering mathematics from 7 PM to 9 PM. Okay, daily on Saturday and Sunday. That is on the weekend. All these subjects will be going on. Once these subjects will be finished, we will come up with the next subject so that your complete course will be finished in this crash course only. Now Many of you know me very well and some of you don't know me. Then my brief introduction is I am Kamesh Srivastava. I am MTech from IIT Roorkee. I have 5+ years of teaching experience for GATE and ECE field. I teach EDC, analog circuit and advanced electronics, and all these subjects I am teaching on the Unacademy Plus platform. From 25th of September, comprehensive course of analog circuit I have started on the Unacademy Plus platform. And if you want to join the Unacademy Plus platform, it is the right time, because very soon fees is going to be hiked for the Unacademy Plus as well as Iconic subscription, and EMFT subject is started from 1st of October only, and meaning is that you can cover up with the EMFT and analog circuit very easily, so that you can come on this platform of Unacademy Plus. If you want, if you are willing to join the Unacademy Plus, you should join right now only, because fees is going to hike very soon. This is the coupon code EDC10 that you have to apply while taking the Unacademy subscription, and you will get the 10% discount as well as our guidance. Okay, our complete team or complete best faculty pool of the Unacademy is available to help the student in all the subjects, and we will make you comfortable in all the subjects, and definitely you will feel very much confident after studying at the Unacademy platform. Now why you should come on the Unacademy platform? Dear friend, Unacademy platform is a daily live classes platform, and all the classes are in the recorded form as well as in the live form. Test series is included in the Plus subscription only. Structure schedule is there. Unlimited practice question we will provide to you, so that you can practice more and more. Personal coach you will get if you take the Iconic subscription. So Iconic subscription is having benefit of the Plus subscription as well as personal mentorship, ECE mains question and answer practice, expert guidance will be provided to you, and study planner will be given to you, so that you can plan your study accordingly and you can achieve maximum marks in the GATE examination. That is the advantage of Iconic subscription. So on the Plus and Iconic, various advantages there. Now, daily practice questions available, test series is available, structure schedule is available, and very much important is every 4th class is the doubt clearing session, where you can ask your doubt. Interaction between the teacher and students is very much good, because in my screen only, on my screen only, I can see the comment of the student and I can give the answer at the right time, at the same time only. That is the advantage of Unacademy Plus subscription. And the course content is also more than the YouTube content. That is the advantage of Plus subscription. Okay, now how to take Plus subscription? If you go for the Unacademy Plus subscription, after application of EDC 10, you will get the subscription in 20,500, and Iconic subscription after application of EDC 10, then you will get 40,500. Don't forget to remember this code EDC10. You have to apply this code while taking the subscription, so that you will get the 10% discount. Okay, otherwise, okay, you can do some mistake. Various EMI options are also available on the Unacademy platform, so that you can take the subscription by the EMI options. So in the per month, your cost will be deducted from your bank account, and you will get the subscription and you can enjoy your class. Okay, so that is the advantage of Iconic subscription or Plus subscription. And now most important announcement, most important point is that whatever you have studied in this class, the same notes, same PDF form notes, I will going to upload on this Telegram channel. Please subscribe this Telegram channel, so that you will be tuned with us for all the announcement as well as for the all PDF format of YouTube lectures you will get on this Telegram group. Okay, and then this is our GATE aspirant Facebook group we are having. On the Facebook, GATE aspirant group is there, where also you can find all the announcement, but we do not upload the YouTube lecture on this. Okay, so you can join this, where you can find out the doubt session, you can ask the doubt to the students, you can connect with the community of the students who are preparing for the GATE and ECE examination. And after that, these are number of YouTube channels are available, where we discuss the content free of cost. And thank you very much for watching me live. कल फिर मिलेंगे tomorrow at the same time from 12 to 2 p.m. we will discuss more number of problems on the diode circuit, and in the four lectures we will complete diode circuit. After that, in the 4th lecture we will complete BJT and BJT amplifier, and after that we will go for the op-amp, and then we will go for MOSFET, and then feedback and oscillator and CMOS inverter circuit we will discuss in a great manner. Thank you very much watching me live. Next session is Ankit Goel sir session. Don't forget to watch live. After that, Vishal Soni sir will come with the mathematics. Don't forget to watch. Okay, like कीजिए, please like this video, subscribe and share maximum with your community so that they can come to know that a great crash course is going on the characteristics channel. So it's your responsibility to inform them by sharing this lecture. Thank you. We are ending this session. Bye bye.